Hey everybody, welcome to the OpenAI plus Azure OpenAI session. And this is a super cool session because we're not just going to be talking about OpenAI and Azure OpenAI. Rather, we have a .NET Convergence story. That's right, there is a .NET SDK for OpenAI. My name is Matt Soucoup, and I am joined by my good friend Roger Pincombe. And Roger, why don't you introduce yourself real quick?
Hey there, I'm Roger Pincombe. I'm pretty invested in this because I actually built the first OpenAI SDK for .NET way back in 2020. And I've been really excited to work with the team to help them launch this new official version.
Yeah, so let's jump right into this. And I really want to hammer home that this is the official OpenAI library for .NET. And so that comes with a ton of benefits. Like, it is official, the official library. And so what we're doing here now is that has feature parity with Python and JavaScript and so on, the library. So day one, we have support for everything. So we have the latest and greatest OpenAI features and models, including like GPT 4.0 and assistance support from day one. And we have a nice unified experience across OpenAI and Azure OpenAI, which we'll be demoing and showing. So we're not big fans of slides here, Roger and I, so we're going to jump right in to some demos. And so Roger, you're going to take it away from the OpenAI side because you have a ton of experience there, and like you said, you have a toolkit that you developed. And I'm going to talk about the Azure side. So let's get going with the .NET OpenAI SDK and show us how it works.
Awesome, yeah. So I want to get started here and just show you the official OpenAI documentation, just to show how nicely everything's integrated in there. So we're here on the OpenAI docs, and on the left side, you'll notice there's a libraries menu item, and there's now a new .NET library section. So you'll see right here, you can just use this example code to get started. So how about we go in Visual Studio, and I'll just paste this right in. So I'm going to actually create a new project. I'm going to show you the complete end-to-end how to build this. I'm just going to make a new console app. It can be any version of the .NET Framework, .NET Core. It's got pretty wide platform support. I'm going to make this here. And then what we're going to do is we're just going to go ahead and manage NuGet packages and add the OpenAI package. Now, what's interesting is if you just search for OpenAI, you'll see this original package. So this is the package I had built over the past few years. The new Microsoft official package is still in beta. It's a pre-release, so you have to click this Include Pre-Release button, and then you'll see that right here. You'll see the official OpenAI logo, so you know it's the right one, and just make sure you grab the latest pre-release version. You can go ahead and install that, and agree to the license terms. And now we've got it here in our project. So let's go ahead and using OpenAI. And now we'll go ahead and just paste in that code we copied from the documentation. So right there, and I'll walk you through exactly what this is doing, but basically creating a new client, calling a model of our choice. Now, there have previously been some questions about model support. The models are just a string. So you can put in any model that's supported by OpenAI here. OpenAI launches a new model tomorrow. You can just put that new string in right there. No need to wait for any updates to the SDK. So that's going to come from, if we go here on the left of the documentation, there's the models section, and you can find the model names right here. And you can select any of these models, just pass it in as a string. And then this environment variable. So as you know, OpenAI is a hosted API, and it requires an API key. So for security purposes, you don't want to put that right in your source code. That can leak if you post on GitHub. It's generally not good security practices. So what we're going to do is we're going to put an environment variable instead. Now, this might be fairly simple, but just for those of you who haven't done it, especially on Windows, let me walk you through how that works. So we're going to go ahead and get our API key. So on OpenAI platform here, we're going to go to the dashboard, go to API keys, and create a new secret key. We're going to give it a name so we know what's what. You can assign it to projects and permissions, but by default, we're just going to make it with full permissions. And now we've got this key right here. And now we need to add that to our Windows environment. So the easiest way to do this is just to open your start menu and type environment, and then you'll see a link to add environment variables for your account. We're going to make a new one. We're going to call it OpenAI API key, and we're going to paste that API key right in there. And so now, if we go back to Visual Studio, so that will basically be substituted in here from the environment variable. So now we'll have a client that's attached to our account. Next thing here, we're going to get a chat completion. So very simple stuff here. We're just going to give it a user chat message that has it echo back, this is a test, and we want to get the response from that. So you'll notice it gives a chat completion object. That includes various metadata, like how many tokens you used and a few other things. To get the result out, we'll just console write line the chat completion to string. This is a helper function that basically takes the first text completion object inside that chat completion and gives it to you as a string. So let me zoom in here as well, make it a little easier to read. Okay, so I'm going to go ahead and run this, and we should see it saying this is a test. While it's building. Awesome, and you see it echoed back, this is a test. Now, just to make sure we're actually talking to an AI here and not just echoing back text, let's have it say it in Spanish. Okay, try this one more time. Awesome, so it translated to Spanish, and now we know it's actually giving us back an intelligent response. So that's a pretty cool example of just how easy it is to get started. But let's say we want to do something more complicated. So you might notice on ChatGPT's website, when you're chatting with it, the results stream in. So you're not waiting for an entire result all at once. You can see the result as it comes in. So this is called a streaming response. So let's go ahead and implement that now. So I'm going to go ahead and create a new method for chat streaming here. And just like before, we've got a chat client. This time I'm going to use the full GPT-4o rather than the mini, because we want it to take a little bit longer so we can see it streaming. And one thing we did earlier is we made it very simple, just complete chat with a single message, but you can actually send multiple messages. So for example, I might have a system message that I want to send, giving some context that you're a poet and you love technology, and then a user message. You can even add assistant messages here. You can give examples of how it should reply. Basically, your messages is just a list of messages that we're going to send in. So now that we've got our list of messages, let's get the results from that. So all we're doing is we're calling complete chat streaming async with the messages. Now it is a streaming async, so there's two different levels here. Let me show you all the different options here. If we do client.complete chat, you'll notice there's this standard synchronous complete chat, which is what we used above, that blocks until there's a response. There's complete chat async. That still waits until there's a full response. It doesn't stream it, but it doesn't block. So it uses the nice async await pattern. We've got streaming, which streams the result back, but does block until it gets a response. And then the fully asynchronous version that we're about to use, the complete chat streaming async. So that is an async await. It returns a task that we just in terms of calling the API, and then we can use the fancy awaited for each in order to get the results. So let's see how we would actually enumerate the results here. So we're going to do await for each, and my autocomplete here is, there we go. So await for each, we're going to go through each item in the result, which is of type streaming chat completion update. So what happens is it actually, update, one second. So what happens is every time the API returns additional data, it returns it as an update. Now this is usually additional text that you can just append to the end, hence this console right here. Although sometimes there's other things in there. There could be metadata, there could be a reason why it stopped. It could ask you to, could give you an image or run a tool. And we'll get into a few more of those details later. But for right now, we're just going to assume that every update is a string that we want to write to the console. And this should be good enough to run. We're basically creating the client, giving the list of messages, asking for completion of streaming, and then for each streaming result, we're writing it to the console. So let's go up here and call this chat streaming async function. And because we're calling an async function from a non-asynchronous function, we have to call wait, and we should be good to go to run that. Give it a second here. Awesome. So you can see the results are streaming in just like they would on ChatGPT's website. It's writing a super long poem here, and we got to see it as it was being written. Now, because we're writing a long poem, we might be concerned about token usage. Remember, with OpenAI, you pay per token input and output, and especially for some of the larger models, that could add up if you use a lot more tokens than you expect. So let's see how we would determine how many tokens we've been using here. One thing that's worth noting is you can get token usage on any chat completion or any API call, but for the streaming results, they only show up on the final result. So what we're going to do here is say, if we have usage information that's been provided in the result, in this update, which will only be on the final update, then we can assume that we're done with the updates, that this is the final part. So we're going to write a line, and then we're going to write out the various tokens here, token usage. So again, we'll have the input tokens, the output tokens, and the total tokens. So let's go ahead and run this, and we'll get another poem, and then we'll get the token usage at the end. Okay, so this one's an even longer poem. It's got longer lines. Definitely curious how many tokens we're using. Okay, so you can see our input tokens was 50. That corresponds to both the system message and the user message we gave it. And the output tokens is a bit over 500. Total tokens is over 500 as well. So that's not too bad. OpenAI is not that expensive, but it is worth tracking this stuff in case you're doing something where you're using a whole lot of tokens. It's good to be able to know how many you're using. Okay, so moving on. Well, just to kind of recap what we got here, we've got chat streaming where we've sent it a couple messages and we're streaming the single results. But there's a whole lot more you can do with OpenAI. So as you may know, OpenAI released a new assistance API earlier this year. And it's really exciting that the new official Microsoft OpenAI SDK supports that, as well as all the other functionality there. So let's make a demo that will actually go through and create a assistant, upload some files to it, ask it to look through those files, and ask it to do RAG, retrieval augmented generation, based on the content in those files, and return results to us. So this is very relevant to if you wanted to understand reports you might have on there, or generate reports from raw data, or if you're doing things like analyzing and writing code, fixing bugs, all sorts of stuff where you might have various files you want it to look at, pull in the appropriate files, and then respond based on that. So let's get started here. We're going to make a new function, assistant with chunks, because we're going to be chunking things. I'll show you how to do that in a second here. Again, we're just creating the client here. We're creating a new file client because we're going to be uploading a file to the service, and then an assistant client. Now you might notice some red squigglies here. That's because the assistant client is currently in beta. So just want to make sure that you're aware that this might still change over time. And it's not fully finalized, but it does work. So in order to move on here, we have to disable the warning. And this will just acknowledge that we know it's in beta and it might change, and now we no longer have any errors there. So the first step we want to do, I mentioned that we want it to be able to load files to go through. So let's go ahead and just open a file from our file system and upload it. So this just uses standard .NET file streams. We're going to file, open, read. This could be any file on our file system, creates a stream. We're putting that file stream into the file client upload function, giving it a name. This is basically the server side name. It doesn't have to be the same as the local name. And we're telling it we want to use it for the assistance. You could also upload files for fine tuning and other purposes, but today we're going to use it for assistance. Now, even though this is really simple and should be intuitive if you're familiar with using files in .NET, in order to make this example very clear so we're not using any extra files, I'm going to just do it all inline. So this is actually fairly useful for demoing and just to get things off the ground here. So what we're actually going to do is we're going to create binary data from string. And this just allows us to have effectively a literal JSON file right here in our source code. So you probably wouldn't do this in practice, but it does make development a lot simpler. So now we've got this document here as a stream. And we're going to go through and upload that. So again, this document is the stream we defined above. We're giving it a file name, and we're again saying that it's going to be useful for assistance. Let me go ahead and fix a few formatting things that came up here. There we go. So now we've basically uploaded this to OpenAI. So it's now there on the server side and will be indexed by their systems. But we have to explain to it how we want it to be indexed. So we actually create a vector store where the file is chunked into and indexed. So let's create that vector store. The way to do that, we're going to make a vector store client. And then we're going to create a new vector store with the options that define the files that are involved. So you'll notice for the sales file, it returned this file info object that has an ID. We're going to pass a list of file IDs into the vector store, basically telling it which files are relevant for this vector store. Now we could in the future add additional files onto that vector store, but right now we're just going to have that single file there in the vector store. Next thing we're going to do is chunking strategy. So by default, the vector store will figure out how to chunk things automatically. It's pretty intelligent. You shouldn't necessarily need to clarify. But as you may know, for retrieval augmented generation, it can be useful if you have a good understanding of what your data looks like to manually define the chunking strategy, depending on how much overlap there might be or how big sections are in your data. So what I'm going to do is I'm going to update this code to use a manually created chunking strategy. We're going to basically say here that we want only 100 tokens per chunk and we want 30 token overlap. So that's going to tell OpenAI how to chunk up this file we gave it into multiple different vectors. And the way we're going to pass that in here is just in the vector store. In addition to the file IDs, we're going to give it a chunking strategy. And that's the file or the object we defined above. Okay, so we've uploaded a file. We've created a vector store to embed the file into. Now let's go ahead and continue making the assistant. Before we make the assistant itself, though, there are a few options we need to specify for the assistant. So that's this assistant creation options here. Basically, we're going to give it a name, instructions. These are basically the system messages, and then tools that it can use. So assistants, just like in ChatGPT, can call tools. There's a few built-in ones like searching the web, doing calculations locally, and also pulling in things from the vector store. So let's go ahead and give it some tools. So here we care about the file search tool definition and the code interpreter tool definition. So basically, we're going to allow it to search the files that we've provided or will be providing, and also run code. So running code will be useful for actually calculating things we want it to calculate based on the sales data. And then we're going to finally have tool resources. So in addition to the tools, we need to provide some additional metadata to the tools to help them work best. So the file search tool needs to know what files to search. So we've created this new file search tool resources with a list of vector store IDs. And that is basically telling it which vector stores it can pull from. So we've got this vector store above. We're taking that vector store, getting its ID, and passing it in as a tool resource for the file search. So we should be good there in terms of creating the assistant options. We've given a name, instructions, tools, and additional details for its tools. So let's go ahead now and make the assistant itself. All that preamble is done. We can finally create the assistant. So what we've done here is we've created an assistant client, telling it the model to use, and we're passing in the options we defined above. Now, the way assistant works, think of an assistant as a GPT. So in ChatGPT, you have this concept of different GPTs. They might have different instructions, different tools they can call, different personalities. But every interaction with that GPT, where you send it a message and it sends you a response, and maybe you send a reply, you have this ongoing thread. So within assistants, we have threads. So here we've created the assistant, but now we need to create a thread that's attached to that assistant. So that's what we're doing here. Assistant client, that create thread. We're initializing it specifically with a message for this thread. In this case, we're asking it for a certain product that was included in this raw data above. for that product. How did it sell in February? And graph its trend over time. And that is the message we're giving the thread to run. And then let's go ahead and actually run it now. So we've created the assistant, we've created the thread, and now we need to actually run it. So you can think of this as the equivalent of the create chat completion we did above, where we are telling OpenAI, okay, given all of this stuff, given the thread we created, given the assistant we created, and given maybe some additional instructions here, for example, we wanted to use puns because of course we wanted to use puns. Now we want to actually get a result. And just like before, we can have it just return the result and wait for it, or we can create a streaming result. And again, the streaming results are a lot better for usability because it helps the user understand what's going on. Sometimes these assistants can take a little bit longer to run. So streaming the results is always a good idea. So now that we've got the streaming updates collection result, let's go ahead and enumerate through it. Similar to how we did before, we're going to go through every update that it's provided and see if the update metadata says that it just started to run. We're going to print that out. We're going to see if it's a content update, and if so, we're going to write out all the text. So in theory, this should be good enough to run now. There's one thing I want to do, though. I want to clean up any usage of all these things we've created, because the assistant and the thread and the files and all those things continue to live server-side, which is probably what you want long-term. You're going to call these assistants multiple times. The files will probably be up there for a long period of time. But in our example, because we're going to be wanting to make sure this runs with a blank slate every time, I'm going to go ahead and clean up all of the resources that we created server-side. And to do this, we're going to delete the thread, delete the assistant, and delete the file. So that should be good enough to run now. I'm going to go ahead and build this, make sure I don't have any silly syntax errors. And it looks like we are all good. So let's go ahead and call this assistant with chunks function and see what happens. So you'll see run started. That means we've returned a response from OpenAI saying that it's already started on the server. Now it's going through and indexing the file we gave it, chunking it, getting embeddings. It's pulling up the appropriate parts of that in order to get a result. Awesome. So here we see, let me zoom in here so you can see it a little bit better. It says that we had a significant sales increase in February, and it's got all that cool information there. It also even made a pun, I guess you could call it a pun, there at the end. So it's followed all instructions. It's intelligently pulled the data we asked it to pull, and it's given us this cool result. But wouldn't it be great if it could make graphs and other images for us? So let's go through here and see how to do that. So we might notice here that we've already asked it to graph over time. So it actually is already graphing for us. We're just not doing anything with it because we're only pulling the text from the update. So let's pull the images from the updates as well. So let's check first if we have any images to pull. So basically, we're checking if there's an image file associated with the content update. If there is, we want to get that file because all it's done is give us a reference to it. What we need to do is actually retrieve the file from the server. We're going to get the bytes of that file. We're just storing it in binary data. And then let's write that to our local file system. Now, you don't have to write this to your file system. You could do other interesting things with it. You could send it to some other service, run OCR in it, whatever you want to do. But right now, we're just going to save it to our local file system. And then we're going to create a new process and launch that file, just basically to pull it up and see what it looks like. And that should be enough to get it going. Let me go ahead and build. And all good. So let's run this. So same as before, we're giving it the same data, chunking it the same way, asking it for the same output. But now if we receive an image, so let's visualize the trend. So it's now receiving the image and it should pop up with an image for us in addition to the text we see. So the way it's generating those images is actually running, I believe, matplotlib in Python on the server side. And it's generating this image and sending it back to us. So that's pretty cool right there. So you can see right here, this is the sales trend it automatically generated for us automatically based on the data that we had uploaded and the command we gave it. Now, the data we uploaded is relatively simple. So it didn't really need to try that hard to find the right data. But you can imagine if we gave it a ton of different documents, a ton of different data, being able to go through and find the right subset of that to plot it is pretty powerful. And everything we've done here basically allows it to do that. So I'm going to real quick just run through one last time all the different sets of functionality here. And then hopefully you can use this to build your own assistants from. So again, we're creating the new client here. We're creating a file client because we're going to be uploading files, and an assistant client because we're going to be dealing with assistants. So each of these different parts of the OpenAI API functionality are kind of wrapped in their own client. You can think that these basically, if you go to the docs here, these more or less map to the different endpoints we have here. So going back here, we've got the document, the document that we want to upload. We're uploading it as a monthly sales file. We're then storing it in a vector store with a manual chunking strategy. We're creating an assistant. And again, this is kind of the equivalent of a GPT. So this is a definition of how a GPT chat might work. We're giving the assistant a name, system instructions, different tools it has access to, and additional information for those tools. In this case, references to the file, the vector store that the file search is allowed to use. We're then creating the assistant itself. We're creating a thread in the assistant, which for each user in the future, we'd probably make a new thread, but not a new assistant. We're giving a message for that thread. And this probably equates to what a user might ask rather than something hard-coded. And then we're getting the results as a streaming result. We're iterating through each result. And if it's text, we're outputting it to the console. And if it's an image, we're saving it to the disk and showing it. And then at the very end here, we're cleaning up everything we've done by deleting the thread, the assistant, and the file. Although in practice, you probably would only delete the thread rather than deleting the assistant, because you probably have multiple users creating new threads on top of that same assistant. But I hope this has been a pretty exciting overview of all the cool things you can do with this new official OpenAI SDK. And now I'll hand it back where we'll go over how this all fits together with Azure.
All right, thank you, Roger. That was great. And a couple of things I wanted to hammer home is that this is OpenAI's SDK for .NET, which is awesome. And we're showing off, or you showed off like the Assistants SDK, and that's some of the stuff that we've heard from the community before. It's like, I want to have access to the latest and greatest from OpenAI, and now we do. We have that, and that's mind-blowing. It's all .NET. .NET's everywhere. You started off by showing us .NET documentation on the OpenAI site. Amazing. So we are there. But everybody's wondering, Matt, you're here, you're going to talk Azure. And I'm going to tell you, you're right, I'm talking Azure. Of course, but just a little bit. And so the Azure OpenAI library for .NET uses the OpenAI library for .NET underneath the covers. So of course we have Azure, up in the Azure cloud, we have OpenAI models that you can totally consume and use. So we went ahead and we built off of the OpenAI library for .NET, the Azure OpenAI library for .NET. So what does that do? That gives you a whole bunch of like Azure goodness along with your OpenAI models that you can use. And so I'll show you like just one that's really, really cool once we get into the code of what that gives you. So how do you use it? There's super, super, super minimal code changes that you need to do. You're just swapping out the Azure OpenAI client or the OpenAI client for the Azure OpenAI client. Most of the code that Roger just showed you stays exactly the same. Really, it's super easy. So let's see it in a demo. All right, so I have everything up here. Roger and I said, all right, Roger, you're going to take the dark theme. Matt, you take the light theme. That way everybody knows what you're doing. And so what I did is I'm pretty much starting with the exact same app that Roger did, but I am going to swap in Azure OpenAI. And so the very first thing that we want to do in order to do that is that there are a couple NuGet packages that we want to put in. And real simple, it's Azure AI.OpenAI and Azure Identity. So Azure Identity is super cool, and I'll show you why we want to do that. But one thing to note is Azure AI.OpenAI, along with the OpenAI by OpenAI package, they're still marked beta, and we're scheduled to release those this Northern Hemisphere fall, Southern Hemisphere spring, to wider GA usage. So they're coming, but you can still start building apps off of them, and as Roger showed you, they work pretty great. Okay, so here we are. The application looks very, very similar. We have chat streaming with tokens, assistants with chunks, but let's Azurize them. So the first thing, other than adding the NuGet packages to it, I'm going to just do using Azure.ai.OpenAI, and then I'm also going to do an Azure.ai. I'm going to do an Azure.ai. I'm going to try to spell right Azure.ai. How about just an Azure Identity? There we go. So I just did some using statements to get things in. Next up is for my chat streaming with tokens. All I need to do really is to swap out my clients. So before, we had the just using the chat client. And all we're doing is grabbing over the OpenAI key that Roger showed us on how we would put that into the environment variables. But with over on Azure, what we want to do is using the Azure OpenAI client, new Azure OpenAI client. So we're using an Azure OpenAI client rather than just the OpenAI client. And I'm passing in a model endpoint here for the where it should go to call up in Azure to get where I deployed my model. So one thing that I do is I have deployed models in different regions and so on. So I'm just saying, hey, Azure or SDK, this is where you should go look. And here, this next part, this default Azure credential, I now no longer have to pass in an API key. I'm saying because Visual Studio's logged into me, or I'm logged into Visual Studio, and I've given myself access to the deployment of where I did my model, I'm good to go. So essentially, I'm using Entra ID, or the old Active Directory, to handle permissions. Super cool. And so that's part of the Azurizing of the OpenAPI. And so then for my chat client equals, how about we call this Azure client. Azure client equals Azure client dot get chat client. And we're going to use the GPT-4. That's it. Everything else stays the same. So it's really just the ceremony of like the initialization of where we want to call it. So let's see it run. We'll cross our fingers that things work. Chat streaming with tokens from our admin. Up, 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 make it bigger. And it's just saying, hello, how can I assist you today? So we'll just say hello and tell us the state flower of Washington. Run it again, and it should tell us that's the coastal rhododendron. I should have been a botanist. And it's saying it's the coast rhododendron. Cool, we are up and running. So the next thing that we want to do, again, reiterate, just changed two things on the initialization, is over in the assistance with chunking, I'll comment that out, or comment that in, save things, go into here. Now, I am going to, again, comment out where it would throw an error if I don't have the OpenAPI key in my environment variables. And see, we are newing in a OpenAPI client. Of course, what I want is the Azure OpenAPI client here. So Azure OpenAPI client. And I'll call it OpenAI client just so I can not have to do a bunch of stuff. And IntelliSense, or probably GitHub Copilot helps me out. Model endpoint, new URI, default Azure credential. Cool, on my way. Everything else is the same. File client, assistant client, building up that in-memory JSON string. One thing, though, I want to change and is the vector store client. What I have to do here is actually use, actually it's the vector store, so let's just go back to new. So there's a minor change. Actually, this should work, I believe. Or hold on. Open AI client. Open. And this one, yes, get vector store. So it's a little bit different. I just can't do a new. I want to actually do this to get it back. And so that's it. That's all I should do. And everything else is still exactly the same as we did it before. Calling in the model when we create the assistant, telling it what it should do, graph its trend, and ideally, it all works. Takes a little bit of time to warm things up because I am using a different model here than what I was using before. I was using GPT-4. Here I'm using GPT-4o. But it should start to say are running and then generate things for me. Run started. Then it's going to tell me and analyze everything and tell me, essentially doing RAG over my data. First it said image saved to. Roger displayed it automatically, but I wanted to save it just to probably send it to my manager to show that I actually did something. And the pun was, it appears that February was very good for sales. I never would have come up with that. So let's see where our image went to. Let's open this up. Open containing folder. We'll go to bin. We'll go to debug. We'll go to net80. Here's our file. And there we go. Looks very similar to what Roger got. Cool. All right, that's it. We have gone through now and taken all of Roger's code for the OpenAI client for .NET, moved it over to Azure, and we showed that one thing, and I want to hammer that home again, is that we just used the default Azure credential. And what's cool about that is I was logged into Visual Studio, and I granted myself access to the deployment of that OpenAPI model, and so I was able to get access to it. Now, if I would deploy something to Azure, all I would have to do is give that service that same access, and it would also be able to access it too. We wouldn't have to change the code at all. We don't care about API keys anymore, so it makes it a little bit more secure, and that's one of the things that you get with the Azure-ness out of it. Roger, how do we do? We covered it. We covered all the greatness of the official OpenAI SDK for .NET. There's so many letters, and we Azurize it.
Yeah, and just to kind of ram home that point again, it is really easy to go from the new OpenAI SDK to the Azure OpenAI SDK because the Azure one is built on top of the OpenAI SDK. So it's really just that authentication change, which if you're already running stuff in Azure, you should be fairly familiar with. API keys from OpenAI or Azure credentials from Azure, and the rest is basically the same. So it's pretty exciting how this is all coming together.
Yeah, super, super exciting, and it'll all be GA'd in a couple, fall 2024, Northern Hemisphere, spring 2024, Southern Hemisphere, so we are very close to having it all GA'd. All right. Well, thank you very much, Roger. I had a blast learning all about the OpenAI SDK for .NET, and I hope you all had fun learning about it too.
Yeah, I'd love to point out there is a migration guide online. Again, we'll share the link to that. But yeah, this is the migration guide, basically explaining what's different from the old OpenAI community library I had published in the past and the new official library. There are some changes. The new official library maps a lot more closely to the actual API. But some of the common scenarios people might have used in the past and how to update it is covered pretty well in here. So I showed you originally where there's links to the libraries, but for each of the sections where it tells you how to do different things in it, you'll notice up here there should be .NET and C# examples in there very shortly as well.
Great. Yep, everything is coming, and we will definitely put a link to an overall collection that people can check out and get links for everything that we just talked about and more. All right, thank you, Roger. I really appreciate it.
Well, thank you all.